Hi, my name is Heidi Seibold, and I'm currently a professor of biostatistics at the Institute of Statistics. And I'm only doing this job for half a year, so I'm sort of a replacement while they find someone else. And I'm giving a talk at the talk session at this institute about the course that I'm teaching this semester. And since I'm already giving the talk and need to practice it, I thought I'd also record it and put it online. So this talk is about a class that I'm teaching right now, so it's still ongoing, and it's about analysis of longitudinal data, but with some parts that go into reproducible research, which I think are very important. So this talk is called Learning Good Research Practices the Hard Way, a reproducibility study in the classroom. First of all, I need to thank the teaching assistant Malte Nalens, who has done a great job at helping me create this course, and of course also the amazing students of the course who are doing the really hard work here. So this is me. I'm a professor for the first time now, and I'm teaching a course which is called Analysis of Longitudinal Data. And so when I started thinking about how to teach it, I thought, what do I actually need to teach in this course? So I went to the course requirements. They're in German, but I'll explain what they mean in a second. But in a sense, the course requirements are very, very short. They say that you have to show different statistical models for longitudinal data, discuss different questions about longitudinal data, and talk about marginal models and models with random effects for normally distributed outcomes, but also other outcomes. So I thought this is actually not very restrictive, and which is kind of cool for me because I'm teaching this course for the first time, and I actually don't have much of a background in the analysis of longitudinal data. I took the course as a student myself a couple of years ago, before I finished my master's, and now I'm supposed to teach it, but which is okay since the course requirements are actually not that big, and I'm definitely willing to learn all these models again and think about them again. So that was okay. So in a sense, there are three main things that the course requirements say that we have to discuss, which are one, different models for different questions, and then marginal models, which I translated as talking about generalized estimating equations, so GEEs, and linear mixed models and generalized linear mixed models. So for understanding this talk, it's not really necessary that you understand what these things are, but it's just for understanding what this course is really about and how I modified it so that we fit both the course requirements into the course and also some more practical things that students, in my opinion, need to learn in order to become good statisticians. So, in a sense, what I really wanted to discuss in this course about longitudinal data was about visualization, about linear mixed effect models, generalized linear mixed effect models, and GEEs. So what are actually longitudinal data? For those who don't know, I created a little visualization. So longitudinal data are all kinds of data that are collected over time, but where we have several individuals. So it's not a time series where we only have one time series, but we essentially have several time series. So we have that a lot in many different fields. So for example, in medical research, you have the disease status over time, for example. So on the x-axis, you see here the time. On the y-axis, that would maybe be the disease status. And then each line is one patient, just as an example for longitudinal data. And so what I've been wanting to teach for a really long time is a course on reproducible research, and I thought maybe we can do both. Have a course on reproducible research and on longitudinal data. So the topics that I would really like to teach at some point, I thought, are talking about registered reports, version control, and in general reproducible analysis. So I think this is a very important skill for a statistician to learn. So this course is for master statistics students, and I thought this would be very valuable for them to learn. And so I decided to create a course on longitudinal data analysis and reproducible research, where we have both topics at the same time. And so this course was really a big experiment for me and a big leap. So I wasn't really sure what was going to happen. And so sort of the students were or are my guinea pigs in a sense. And I am my guinea pig as well. So we're really trying something new that I've never done before. And I think so far it really worked very well. Just as a teaser in advance. So what was the timeline like? What did I do to create this course and make this course happen? And how did I actually combine these two topics? So I thought maybe it would be a nice thing to take some papers that are already out there in the literature that are combined with an open data set, so the data must be openly available. And why don't we try to reproduce these papers? And of course, these papers have to deal with longitudinal data in order to fit into this course. So I thought, maybe I can get a journal to help us. And the journal that I thought of first was PLOS ONE, because I thought it would be nice if we have several different topics, not only like from one field, but from several different fields, so that it's interesting to a broad range of students as well, who are not only biostatistics students, but we also have different statistics masters, where we have students who are interested, for example, in the social sciences or in economics or in other fields. So I just try to figure out on the PLOS ONE website how I could contact someone. And so just to say that another reason why I chose PLOS ONE for this is that they are an open access journal, which I think is important, and also they have an open data policy, so they ask their researchers to make their data openly available. And so I thought this would be a good combination with my goals, and also they have a statement that they're interested in open and reproducible research. So I contacted some person from PLOS ONE because I didn't know who to really contact. And through this person, I got eventually to the right person to talk to. And they were actually from the beginning very enthusiastic about my idea. And they really were very, very helpful. So in the end, what PLOS ONE did for us was to, give us really some very valuable help in the paper selection. So they sent me papers, and then I reviewed the papers if they're usable. But like the pre-selection, they really did for us, which was a big, big help. And I think I wouldn't have been able to do it without them. So we did then the paper selection before the course started. So I had a lot of work to do before really the course started in selecting the appropriate papers. And I will discuss the details of the paper selection in a minute. Then I also, of course, wanted to pre-register our course, and the idea of the course, which was I wanted to select appropriate papers that use GEs or mixed models for the analysis of longitudinal data, and then see if we can reproduce them, and then eventually also publish these results. So I, together with Malte, wrote a registered report, which we submitted a couple of weeks before the course started. And Plus One told me that they would be very fast in trying to find reviewers and getting the reviews back. And we hope that by the end of April, so that was just shortly after the course started, we would get the reviews back. In the end, that didn't work out that well. We got the reviews back a lot later than we thought, and resubmitted a new version of the registered report. But of course, we had already started with the course, so we have to here be also a bit pragmatic, because we couldn't change the timeline when the course starts and when the course ends. So in a sense, it's not really a registered report anymore, but it's better than having nothing. Yeah, then now we're somewhere close to the end of this course. So the course will end in a few weeks, and we're quite advanced with most of the projects already. The plan for after the course ends is that some of the students will review the students' projects before they submit it to us, to the teacher. So they're writing short essays about their projects, and of course provide the code that they use to reproduce the original study as part of this essay. And then after they submit that, they will be graded by us, and we will try to write up a paper, hopefully until the end of this year or beginning next year. So this is just a quick overview, and I'll get into details of some of the ideas here. So what's the overall setup of this course? We have now selected 11 papers, so we have 11 groups of students that work on reproducing these papers. So we have just below 30 students, so we have 2 or 3 students per paper, so we have groups of 2 or 3 students. So the main aim of the course is now to reproduce the results from the papers, and since all of these papers discuss longitudinal data and discuss at least one of these models that we're interested in, sort of the principle of the course is we learn what we need to reproduce the papers, which I think is a great way of motivating why we're learning all these methods. This principle, learn what we need, is creating students who sit there and say, I want to learn how to solve the problem of my project. And by that, they're really enthusiastic about really learning all these different skills and learning about the models in depth. And I feel like by now, most of the students are really experts about the model type that their paper discusses, and are good enough in understanding all the other models that they should learn about. So I feel like for some of the students, they have a more in-depth knowledge about the models by now than I have, which is actually a great success, I think. So students who really want to learn is, I think, what teachers should try to achieve. And this project was a way that I thought would be a good way to do that. And I really hope that the students really think the way that I think they think, which is really hard to say, but I think most of the students seem very enthusiastic. At least in front of me. So how do we select the papers? In a sense, I already gave the requirements 2+1. So I said, okay, the paper should discuss a longitudinal data and use either mixed effect models or generalized estimating equations. and the data should be openly available online. So what they selected was really based on the longitudinal data and then on the models, and they sent me 57 papers that then I reviewed, and only for 15 of them the data was openly available, and then out of these I wrote emails to the authors and asked if they were okay if we use their paper in our reproducibility study, because I wanted to have authors that would respond to requests of the students, because I thought probably some of the students will have to contact the authors in order to reproduce the results, and I thought I don't want to work with people who then get angry or don't want to work with us. Yeah, so these were the selection criteria for our study, and unfortunately we did a mistake, or I did a mistake at the very beginning, and I selected one of the papers that didn't really have a mixed effect model or a GE, and so in the end we ended up with even one paper less. So in the end we had 11 papers, so 11 groups of students. So what were the study questions of our study? Mainly we wanted to do a replication study or reproducibility study, but we had several different questions. So first question was which methods are actually used in these papers. So which papers use GEs and which papers use mixed models. And then the second question was which software is used. So I'm interested also in whether the authors use open source software or how they make the software available as well. So are the codes, the software codes available that they used for analyzing the data? Yeah, so then of course we have the question, are we able to replicate the data analysis? And another thing that we were interested in was what are the characteristics of a paper which make a reproducibility of the results easy, or on the other hand, what makes it hard or even impossible for us. So we were not only interested in learning how to replicate a data analysis, but also in learning how we can make it, how can we do it better in the future? So what do we suggest that authors do differently in the future? And I think this is also an important part for the students to learn. So if they eventually become researchers, they now know how to do it better and what actually stops people from being able to reproduce the results of a study. And then, of course, what are other learnings from the study is the last question. So what do we learn about reproducibility studies in general? What do we learn about papers, about statistical analyses, and so forth? So that last question is, of course, a very open-ended question where we didn't know in advance what would come out there. So going into detail on the question that was, I think, the most important, are we able to replicate the data analysis? So there, the first question is, of course, are the methods documented? And that's actually a very important question, especially in this field of longitudinal data analysis, because the models are rather complicated and you have to specify very clearly how you specified the model in order for others to really understand what you did. And then the second question was, did we need emails? Did we need to send emails to the authors in order to be able to replicate the data analysis, and how many emails did we need? And then finally, do we actually receive the same or at least similar estimates? So sometimes we have different algorithms that are underlying in R than in, for example, SAS. So we did all our analysis in R because that's what the students here in Munich learn. And also I think it's a good way to do open and reproducible research is in R because there's a lot of infrastructure, and also it's all open source. So we used R, but the original authors obviously did not always use R. So sometimes we get different estimates just because probably the algorithm that computes the model works a little bit differently, and so it's okay if the estimates are very similar, but not exactly the same. Yeah, so what were the course format? So we didn't really do the usual lecture exercise combination that we usually use here in Munich to teach statistics. So usually in this course we'd have every week 2 or 4 hours of lecture, and then every second week we have an exercise. In this course we didn't really do this strict combination. We did very few sessions where I really stood in the front and did a lecture, a classical lecture. That are the things that I only did when we learned new material. But after every phase where I did lecture, we always did a group work where we try to figure out how do the things we just learned apply in the projects. And there we did a lot of group works where we printed out parts of the papers, and then the groups discussed what that means for what the material means for this project, and what are still the things that after we learn about this method, for example, what are still open questions that we didn't understand in order to really understand what they did in the paper. And that was very helpful for me as well, because I always got feedback from the students on what they wanted to learn next, and or where they thought they needed more deeper information on a certain topic. And we did also some hands-on project work as part of the course. This was mostly what Malte did in the sort of exercise sessions. And we also tried applying new tools. So, for example, we learned Git as part of the course, and we did some sessions there where we tried that, or we did also some practical sessions on other things. And I mean, the course was had very little structure. We always told the students in advance what the next session would be about and how the next session would be organized, but they couldn't come and just think, okay, today I'm gonna just sit there and listen, because that was never what happened in the end, really. So they always had to participate. So what are the tools that we used? So for organization, we used Moodle. So Moodle is an online learning platform, and our university has an instance of Moodle. And really, I think by now most of the courses are organized there. So what we did using Moodle was essentially write emails to the students. So through the platform, you can notify the students. So for example, we used that to send out emails to the students about what the next lecture would be about. And also it contained information on the essay, on the registered report, and what the course is about in total. Then as a next tool for organization, we used GitLab. So our university uses the GitLab instance of the Leibniz Rechenzentrum here in Munich. So we have a university-wide GitLab that's used by some other institutions here in Munich as well. And that's just like GitHub or the general GitLab. It's a online instance we can use for version control and organization, and we use that in combination with the version control system Git. So Git was also something that the students had to use and had to also learn as part of this course, but I think this is a very good tool to learn anyway. And then for computations and reports, we used R, because it's open source and it's what the students already know anyway. And we used R Markdown we are using R Markdown for the essays. So this is of course still ongoing because the semester hasn't ended yet. So we were still in the middle of it. Yeah, now I also want to talk about some of the problems that we faced so far. So what are the learnings so far? What are the problems that we ran into? And the main message that I want to convey here is has never been a problem of us that there was too much information. So too little information was usually the problem that we had. And so main problems that came up were that we didn't know what the covariates are, what the fixed effects are. It was mostly possible to figure that out, but it wasn't really clear. So especially what are the fixed effects in the mixed effect model was not always clear. The same in the generalized estimating equations. You have to specify a covariance structure, and that was not always given. A lot of the papers did either not comment on it at all, or they said they used a selection strategy to select the best covariance structure. And so this was not always super helpful because it was sometimes not very clear how they used this selection strategy. And so we, in the end, often tried just different variants of the model that could be possible, and then selected the one that was closest to the reality. And sometimes we wrote emails to the authors asking if that was really the correct model. We had one project where we didn't understand how to read the data, and I'll go into that in a minute. And really, most of the papers didn't come with code, so code was rarely really available for the different papers. If code was available, that was really super helpful. Even if it was SAS code, then we could really much more easily understand what they did, even if we then had to implement it in R in the end. So, but really it was a good help if the code was available. So I want to go into two interesting problems that we got into. So some of the students had issues with selecting the right data set from the website. So for most of the groups, it was really, really easy to just download the data set from the PLOS ONE website, but sometimes there was a link to a database somewhere else where they had to select the data sets, and there it wasn't really clear which data sets they had to choose. And so in these cases, we just decided to write emails to the authors and ask back about the data sets. And then there was one group in particular where it wasn't clear at all. They had some sequencing data, and I mean, we're all statisticians, so none of us was a bioinformatician, and for us it really wasn't clear how to deal with this data set. So the link from the paper went to a website with sequencing data, and you see here in the screenshot of this project that there were 32 pages with data sets. And we really didn't know how to deal with that and what to do with that at all. And so we wrote a couple of emails with the authors, and they told us that there's a tutorial, but even with the tutorial, we couldn't we didn't know what to do. And the tutorial was written probably for bioinformaticians who already know how to work with this type of data. In general, for us, it was really not possible to understand that. And at some point, we decided that we're just gonna call it a day and say that we're just not able to reproduce this paper because the data is available, but not in a way that we can really use it easily. And I'm not saying that the authors did a terrible job here. I mean, they were really already one of the best authors in the world because they put their data out there. They provide a tutorial on how to use the data, but even the tutorial was already so far away from what we would be able to understand in half a year. Like, I just said at some point, okay, we just let it go and say that this is one of the papers that we were not able to reproduce. We just need to be open about why we weren't able to reproduce it. Then we had one group where we had a very specific model, and it was not so easy for us to figure out which model in R we would need to compute this model. So the original paper had a linear mixed model that where they specified a certain correlation structure and they had non-nested data. So this is very specific now to the mixed model world, and if you're not in that world, it doesn't really matter. So the problem there was that there's different packages for mixed models. So the most famous ones are LME4 and NLME. And so LME4 doesn't support correlation structures, so we couldn't use that. And NLME doesn't allow nested data, so we couldn't use that. So what I did is I went on Twitter after we had the discussion and couldn't find anything by ourselves. I went on Twitter and asked if they could help us. So the original analysis was done in SAS, and now we wanted to do it in R, and really people on Twitter were super helpful, and we got a lot of replies, and especially the student group also went to Fabian Scheipel, who is here at the Institute, and did a great job in trying to help them as well. But also here, in the end, we said, okay, we can't really find a good solution for our problem right now, and we're trying something that comes close to the original model, but isn't able to really reproduce everything. But because we couldn't find an already good implementation in R for this. So I think we really created students, so especially this last student group, I think did a very good job of trying to figure out how to compute this model that the authors did in the original paper. And they also told me that they learned so much in the process that even though they're not able to really reproduce everything now, they have this great learning experience and really understand the model very well now. Currently, we are almost at the end of the semester, so we're trying to soon wrap everything up and start writing the essays. And what is the current state? So as I already said before, one paper should have never have entered the class, so that's why in the end we didn't have 12 papers but 11. One group was never able to read in the data. One group was not able to find the implementation in R, so these are the two groups that I just discussed as well. And some of the groups are close to being done. Some have already gotten the same estimate, so this is really promising. And some of the groups need a little bit more time, but I think all the groups are at least close to being done. And the one group that never got the paper, never got the data in a way that they could use it, they are now getting a new task. So they're still writing the essay, but since they have a lot less work in reproducing results because they can't, they're now helping the other groups. So they're now the reviewers for the other groups and trying to get them into a good state before they submit their projects to us for grading. And I think that's a really nice thing to have as well. And I think that's a win-win for everyone in the end. So I think one of the most important questions was doing such a risky course where I didn't know what was going to happen, was it worth it? And I would say definitely, for sure. I learned a lot, and I think the students learned a lot. And if we're going to be able to also publish these results, then it's not only a great teaching experience and a great learning experience, but also a nice start for the students in their career, and obviously also nice for my academic career. So I think if we're really able to get this wrapped up nicely and get the students' projects in a nice state so that others then can also reuse the analyses in later on, and we can publish everything, then that would be like a project that's a huge win for everyone. And I mean, of course, it was a lot of work, but research and teaching always is. So I would say it was definitely worth it. And I mean, most of all, it was lots of fun for me. And that's what's really cool about this. So the conclusions I have so far. Although data is open, it's not always easily usable. So open data doesn't mean that it's, for example, fair data or reusable data. R is, after all, not able to do everything. So I always thought R will be able to do all these tasks anyway without any problems. It almost was, but not quite. So there are still packages that need to be written, and we're not going to be, it's not, there are some things that are implemented in SAS that are not implemented in R, apparently. So, and I think the most important point is that authors are not aware about how much information is needed to really understand what they did. Because I don't think that authors write less than is needed to understand because they want to, or they don't want to share that information. I just think they're not aware of how complex reproducing results really is. And this really was complex, and it's really continuing to be complex for the students right now. But I think this will be a good learning experience for everyone in the course to really see what is needed, and so that in the end, if they want to go into research, they become really good researchers. And that's the goal, right? That's why we're teaching. So these slides are openly available. You can reuse them, of course, as well. So they're under CC BY license. Also the drawings that I did myself, you can reuse them, and you can also contact me if you have any questions or follow me on Twitter.